C++ Programming Comprehensive, Chapter 2, Unit 6, Memory Management. In this unit, we will discuss how C++ manages the dynamic memory. It provides the operators new and delete to allocate the memory and deallocate the memory from the heap. So new and delete operators are used for memory management. New and delete operators create and destroy data objects at programmer's will. You must have done a memory allocation in C language by using a malloc or calloc, but C++ provides a new operator to allocate the memory from the heap dynamically at runtime. So it is programmer's responsibility to destroy the allocated memory during the program, when the program is running. Data objects created by new operator stays in the scope throughout the program. Now, if the programmer does not destroy the data object, it will stay in the memory even after the program is stopped. Okay? Now, that is considered a memory leak because the memory was not returned back to the operating system as expected, meaning no delete operator was used in your program. So that's why the memory leak will occur. So by using a delete operator, data object goes out of the scope. So it is programmer's responsibility to use a delete operator within its program. So let's look at this small example. In this example, you will understand how this single integer is allocated in the heap, okay, at runtime. So the very first line, a zeroed line, as we have discussed in the previous chapters, we call the header file IO stream because in this small program we are using a cout object, and cout object requires that you include IO stream header file. Since cout object is in the namespace called std, that's why we have to include or use this line number 2 using namespace std. So now we can use the cout object without using the scope resolution operator, as we have seen it in the first chapter. So at line number 4, I have a main starting at line number 4, and at line number 5 is a curly braces for the main. Okay. At line number 6, I have is a comment which will end at the end of the line right here. Now line number 7 is the key thing. Line number 7, very first thing, I am creating a pointer. Where am I creating a pointer? Of type integer. I am creating a pointer on the stack. Okay, so this pointer is basically created on the stack. The pointer name is ptr num. Okay, it probably will be created at some memory location. We call it 2000. So, and its type is integer. What does that mean? That means the data object that you create must match with this pointer type. Now, on the right hand side of the assignment operator, I am creating a data object for one integer. Okay, integer could be a 2 bytes, 4 bytes long, but this will be created on the stack. This will be created on the heap. So one integer will be created on the heap. Okay, somewhere here. So in the computer, you will find there are different kinds of memories. There's a heap memory, which is huge, and then there's a stack memory, which is very small, and then there is a memory which is called static memory, and then there is a memory for your code section. Okay, so in this line number 7 on the right hand side, we use a new operator to allocate a one integer memory from the heap. Okay, so we in our case, to keep things simple, I'll just say the processor supports 2 bytes for the integer. Okay, but this memory will be created at some memory location at 5000. The one thing that when you allocate the memory using a new operator, the new operator's responsibility is to get the address of the memory that it allocates, pick that address up, and assign it to the pointer variable, which is on the left side of an assignment operator. So pick this address, 5000, and assign it to the pointer variable. Now, as you can see, this pointer variable is pointing to the integer memory. But this integer memory does not have anything. It could have some junk in there in the data side. So at line number 8, what we are doing is we are dereferencing. So when we put a star in front of the pointer variable, that means we are dereferencing, and dereferencing will allow us to reach to this memory that we just allocated, the integer type. So basically, by dereferencing, we are writing 100 to this memory location. So now, once the memory is written at that location, it of course will override whatever the junk was sitting in there. At line number 10, basically I'm using a cout object to display whatever was written to the integer type memory. Okay, so first it will write this string, and then it does the dereferencing to get the value of this memory location. So it does the dereferencing of 5000 and it will pick up the data 100, so it will display 100. Now at line number 11 shows that I'm using a delete operator. Okay, line number 11 shows that I'm using a delete operator on the ptr num. So ptr num for us is the allocated memory in the heap, okay, which we we did it at line number 7. Now, please understand, by delete, when we use a delete ptr num, that doesn't mean that we are deleting this ptr num, this thing. We are not deleting this. This is on the stack. We cannot delete that. But what we are deleting is this memory right here that we allocated. That's what it is going to be deleted. Okay. So delete operator will go and remove this data object from the memory. If you don't delete it, if you don't use this line number 11, altogether, meaning the delete operator is not there, and then you go to the next part of the code, this memory still will be allocated, and that will cause the memory leak, because at the end, when the program finishes, this piece of memory will still be sitting in the heap, and therefore we must delete this memory. So let's go to the next slide. And next slide, basically I do the similar thing what I did for the integer. In the next slide, in this slide, basically I'm allocating the, first of all, I am creating a pointer to a character that will be created on the stack. Okay, so this will be a ptr char, okay, and then so this is a pointer, so it will be created at some memory location, let's say 3000, and then on the right side of an assignment operator, I'm saying allocate the memory for a single character, that means 1 byte. Okay, where is it going to be allocated? It will be allocated in the heap. So this memory is on the stack, okay, and this memory is on the heap. Okay, same way this memory will be allocated somewhere and on some address. So we'll just say it was allocated at address 4000, and then as we talked in the last slide, that new operator's responsibility is to, after allocating the memory, to pick up this address and assign that address to pointer variable right here. Okay, now this pointer variable is pointing to this allocated memory. Okay, and then at line number 16, all I'm doing is doing the dereferencing right here. Okay, I'm doing the dereferencing on ptr char, and I'm assigning s right here, a character s. Okay, so ASCII value of character s will be assigned right here in the heap where we allocated the memory. And then at line number 17, I am saying that print this string and then dereference the ptr char. So when we dereference the ptr char, we come right here, dereference it, and we will have this s in there. Okay, so it will print out s right after this string. And then at line number 18, all I'm doing is the same thing as in the previous case. For the integer, I'm deleting this data object for the character type. So this will be gone at line number 18. This will be out of the scope. This memory will be gone. Now it is very important again to understand that if you don't use this line number 18, then you will have a memory leak. Memory leaks basically are not good because they can cause a malfunction to your program. Now it depends what kind of a program it is. So let me just give you a quick overview of memory leak. Now, a program like this, if the program is just running one time and is stopping, and depending upon what operating system that you're using, let's just concentrate on Unix and Linux. So on Linux and Unix, these programs are considered as a processes when you start running. So once the process starts, the operating system or the kernel gives a process its own memory or the address space to run. Now, once it stops, the memory address is returned back to the kernel. So everything is released. Even if there is a memory leak, everything is gone back. But there are programs which never stops. And the biggest example I can give you is the web server. Okay, web server is a program where you actually go to different websites and visit. Now, web server supposedly runs year after year. Okay, they never stop. The program, your computer does not stop. So within the web server, if there is a memory leak, then there is a big problem, because let's say that every user, when they come and visit the site, within the user login process, the memory is allocated for the user, and then the programmer just forgot to use a delete operator. So every time new user comes in, gets a new memory, and when the user exits, the memory doesn't get deallocated or released. So then eventually what will happen, because kernel or the operating system has given that web server its own memory address space, because it's just a process, it's just a program. Web server is nothing but a program. So then it will eventually run out of its own memory address space, because the memory which is supposed to be getting released every time the user exits its own login process, it was never getting released. So that's why eventually that web server will crash. Okay? In those kind of programs, it is very important to remember to release the memory as soon as you are done, meaning delete the memory. Okay, so let's go to the next part of this small memory management program. At line number 20, basically I am doing the commenting allocate memory for array of integers. So in this case, I just want to show you, you can create not only one character, not only one integer, but you can create an array of integers. And then you can go to any element within that array by using the index. So to do that, again, we have to have a pointer of whatever the type of array that we are going to be creating. In this case, we are creating an array of integers. So I have a pointer called array num. Okay, so this is array num created at some memory location 5000. Okay, and then on the right side of an assignment, I say, okay, I want to create a 10 integers. Okay, right here, 10 integers. That means I want to create array of 10 integers in a, one after the other one. So they will be all together in the memory. So this basically is an array of 10 integers. So it will start from location 0, okay, and then 1, 2, 3, 4, 5, 6, 7, 8, and this is 9. Okay, so 0 to 9, which is 10. Now this array will be created at some memory location in the heap. So this array is getting created in the heap. The array, this pointer right here that we have, is on the stack. So this will be on, I would say, just 6000. So when we are creating an array, as we have talked about new in the past, that the new's responsibility is to pick up that first address and assign it to the pointer variable. Okay, so that's what we are doing, assigning it to the pointer variable, and that means now the pointer variable is holding the very first address of an array. Now, since it knows the very first address of an array, it can go to the different elements within the array. Okay, so now we have the memory allocated for the array in the heap, and the pointer variable itself is on the stack, array num, at some address 5000. So at line number 22, I'm using a for loop to index inside the array. Okay, so I start the for loop. We already have discussed in C++, allows you to create a variable and initialize it all at one time in the initialization section of the for loop. Okay, so that's what it is happening. I has been getting created locally and getting initialized with a 0. And then I compare I is less than 10. So I will be, first time it will be less than 10, of course. Then I plus plus. So we also discuss that the scope of I will be only one statement after the right parentheses of the for loop. So after this statement right here, the scope of I will go away. So that's why we have in line number 23 another scope. We are recreating the I again. So basically in this first for loop, all I'm doing is initializing every element of the array with some integer value. So the first one will be, since the first one I will be 0, so 0 plus 1 will be 1, and then this will be 2, and then this will be 3, and this is 4, and this is 5, 6, 7, 8, 9, and 10. Okay, so these array elements are going to be initialized. As you can see right here, array num itself starts from what, 6000, right? That's how it knows 6000 right here. As we said, array starts from 6000 and then the very first element of the array is 0, so it's basically a 6000, and we are writing 1 to the 6000 location as I did already. Okay, and then 6001, 6002, 6003. Well, depending upon the size of the integer, the offset is based on that. Okay, so this would be 6000, and then this could be, if the integer is 2 bytes, then it will be 6002, or if it's an integer is 4 bytes, then this would be 6004, and so forth. So at line number 22, all we are doing is initializing the array with all these numbers. Line number 23, we are reading the contents of these array elements, okay, right here. So again, the for loop will have initialize I, okay, I will be initialized, I first will be declared and initialized to 0, and then compared with less than 10, and then we have the array name, array num, and ith value. So we go through each element of the array. Once all this is displayed right here, okay, we come to line number 24. At line number 24, I'm using a delete operator. What is a delete operator doing? Delete operator is basically making sure that the whole array, this whole array is getting deleted. Okay. Now, it is making, the reason that it is going to delete the whole array is, this is the specific syntax. This square brackets. Very important that you remember to put in these square brackets. If you forget to put in these square brackets, what will happen? It actually will just delete the very first element. That's it. The rest of the element will be in the memory. All these will be in the memory. Okay? If you forget to put this square bracket right here. And that will be considered as a memory leak. So this is a basic example about a new and delete operator that we just discussed, allocating a one integer, a one character, okay, or a 1 byte, an array of integers. That's what in this example that we went over. So now let's look at the next example and see how we can utilize the new and delete operator for multi-dimensional array. Okay, so we will try to understand how this same concept can be applied with the new and delete to allocate the memory from the heap for a multi-dimensional array, or in this case, actually a 2-dimensional array. So again, line number 0, we are including the header file, IO stream. On line number 2, we are saying using namespace std. That means we are making sure that cout and cin objects are in the scope of std, and then we start the body for the main. Within the body, at line number 7, I'm creating or allocating a memory for x, y, and num. This memory is going to be allocated where? On the stack. Okay, and num is also initialized. Now, line number 8. On line number 8, I have a pointer variable. In this case, this pointer variable will be pointing to a address of an address. Okay, that's the reason it has two stars in front of it. You see these two stars. So it will be pointing to an address of an address. Okay. In the previous case, we had a pointer variable with only one star. That means it was pointing to the address location of another piece of memory, but that piece of memory had the data in it. In this case, we'll be pointing to a address, and that memory will be pointing to another address, and that will have the data in it. So let's look at it, how all this happens, or how all this works. So at line number 8, very first thing what we'll do is to create this PN matrix pointer. Okay, this PN matrix pointer will be created somewhere on the stack at address 5000. Okay. Now I also understand that I'm just picking up these numbers, okay, but that's how the compiler or when your program is running will allocate the addresses in the memory. And then P and matrix will be at this 5000 address, and then see this is P and matrix is assigned with 0. In C++, it means this pointer will have the starting value of this pointer will be null, meaning we are making sure that within this it's not pointing to anywhere. It's just the memory is clean for it. Okay, it's not holding any weird addresses. At line number 9, what we are doing is we are allocating array of pointers. Okay. First of all, we already have created PM matrix, and then at line number 9, on the right side of the assignment operator, we are allocating the array of addresses. How big array? It is going to be, because it's and numbers, so it is going to be size 10, because I need the more room. So I will create array of pointers right here. Okay, so I have 10 pointers, so 2, 3, 4, 5, 6, 7, 8, 9, and 10. We start with a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it will go from 0 to 9. So now, remember, these can only hold, these all array elements can only hold the addresses. It cannot hold the data. And that's what we were talking earlier. Okay, this pointer right here, PN matrix, will hold the address of this array, the very first address. So this array might be sitting at address, let's say, so this address, the very first address, might be sitting at 7000. Okay, and then when we allocated this array, the 7000, the new operator will pick up the very first address of this array and assign it to PN matrix. Okay, so 7000 right here. So now PN matrix is pointing to right here. So now, as you can see, PN matrix is holding the address, okay, and it is pointing to a memory location where it is 7000. Now, each element of array will hold the address. as we will see it at line number 12. So at line number 11, first let's check it out. Line number 11, we have we already have created the memory for the x, so we are just initializing x to 0, and we are comparing x is less than n numbers and x plus plus. So then come to right here at line number 12 and saying that on the right side of assignment operator, allocate the data array. Okay, as you can see, there is no integer right, there is no star in here. Okay, there is a star right here. So that means we allocated this array right here. Okay, this whole array we allocated. That means basically it will hold the addresses. So when we come to line number 12, we are allocating an array, okay, that is going to hold the data in here. Each element of array will hold the data, some integer data, because it's an integer array as well. So this array, could be allocated at address 8000. Okay, so the very first element would be at 8000. So this 8000 will go right here. So now we are saying that this first element of array of pointers or array of addresses is pointing to the data array, which starts from address 8000. Okay, so now look at it. The purpose of having a 2 stars, okay, these 2 stars, because the first pointer, which is holding the address, which is pointing to some memory which also holds the address. Okay, that's why we have a 2 stars. Okay, and then the next which is array of pointer is pointing to a data array. So that will hold some data depending upon how we initialize it. Okay. So since it's in the for loop right here, hold this array of pointers. Okay, all this will be pointing to these arrays right here. Okay, this as well. Every one of them will be pointing to the 10 data arrays. 10 element data array. Okay, up till right here. So, and that's why, as we have discussed earlier, the responsibility of new operator is to pick up the address of these smaller arrays or the data arrays and assign it to the pointer variable, and that's what this for loop does right here. Okay. At line number 14, I have a nested for loop. Now I already initialized or created the both array of address and data arrays. Okay. At line number 14, what I'm doing is I am going inside these data arrays, okay, this data array, and initializing each element with some data. Okay, so to do that I need to have a for loop. Okay, what's the purpose of the for loop? The first for loop, which is going to allow me to go to this array of this array right here, which is array of addresses. Okay, and then the second for loop allows me to go to each smaller array or which data array. okay, and initialize the element. So now let's look at it at line number 16. What is this all about? So at line number 16, what we are looking at it is that Pn matrix in square bracket x. What does that mean? That means it will give you the address, this address right here, for example, okay, plus y, whatever the value of y is. So the first time y will be 0. So first time the y will be 0. So it will be saying this one right here, this location. And it is saying dereference that location. Okay, so when you dereference it, you're writing some value y right here, 0. And the second time y, second time x value still will be 0 because we are right here, and then plus y will be 1. So we move to the second location in array, okay, in the small array, and then we dereference that value, and then we write the value of y, which will be 1, okay, and then we basically go up till this condition becomes false. Okay, so in this case we get 2, 3, 4, and then the last one will be 10. Well, actually last one will be 9 because we started with a 0. So we initialize, so that was for this first array. Okay, now how do we move to the second array? So for the second array to move, when this finish initializing the first array, the for loop will come back to here, okay, and x will, the next time the x will become 1, so then it will come and start this one, and then this is the x values right here. These are x values, these all are x values, and then basically we will be sitting at this address in the array of addresses. Okay, so we are saying, now we are saying that this, whatever this address is, we go and plus the first one, again y will be 0, so we dereference, so it will be pointing to the, because this array address, the first array location address will be sitting right here. When we dereference it, we are looking at this first element of this data array, and then we write a value right here, this whatever the value is. So in this case, we will be writing a 0, okay, and then keep going in the loop right here, okay, until we finish writing this to a whole array. So eventually we finish the array of pointers and writing to the data array this way. So this nested for loop, that's what it does. Now line number 18. Line number 18. What does the line number 18 does? Line number 18 basically, and again we have a nested for loop starting from line number 18 and 19. This nested for loop is for displaying whatever we initialized in the data array. So now look at it. This Pn matrix right here looks a little different, but at line number 16 and line number 20, okay, Pn matrix does the same job, gets the array locations. So at line number 20, we are picking up what we initialized at line number 16. Okay, so each data array, these data array values will be picked up and given to the cout object for the displaying purpose. Okay, so it's going to go through this whole array of address, okay, plus the data array. At line number 22, once all this thing is displayed, all I'm writing is a new line character, so the cursor will be sitting at a different line. Now in this slide, I allocated the memory, okay, with a new for the purpose of array of addresses, which is this one, okay, and for the data arrays, these are the data arrays. Okay, but I'm not calling the delete operator, okay, which is in the next slide right here. So now notice that I have to make sure that I remove the memory, meaning I have to make sure that I delete both data array and array of pointers. So first I have to make sure I delete the data array. So this one at line number, starting from line number 25, all these small arrays that we created will be deleted. Okay, so it goes to each, first it goes to the array of pointers, okay, first element, and then second element, okay, so it will delete each one, these arrays will be deleted, each one of them, by this line number 26. Okay, again remember, if you forget to put in this square bracket, what will happen? It will just delete the first element. Okay, that means it will lose the pointer, and then the rest of the array will be in the memory. This part, okay, that will be the memory leak, and you want to make sure we avoid that. Okay. And then at line number 28, once all these are gone from line number, these all data arrays are gone, then at line number 28, we'll delete this array of pointers or array of addresses. Okay, again, since P and matrix is a pointer on the stack, this is pointing. Okay, so if you forget square bracket, it will just delete this one. Okay, and then the rest of the array of address is still going to be there. So how is this? This is going to be deleted. PM matrix, which you understand. That pointer is going to be deleted when the program ends. Automatically it will go out of the scope. So that's how the dynamic allocation of the two-dimensional arrays work in C++ using a new and delete. So let's look at the next example. Now in next example, basically we are going to use the new operator to allocate memory for an object. So that means class object we are talking about, and then use delete operator to remove an object from the memory. So we will allocate the object in the memory, okay, on the heap, and then we will use the delete operator to remove the object. So at line number 0, I have IO stream header file included, and then at line number 1, I have a C string, which line number 1 I have a C string header file, which is used for memset function. Okay? Memset function allows you to initialize the memory to whatever you want to. And then at line number 3, I have a using namespace std, so we can use the cout object easily. And then my class starts the C employee class. Start at line number 5. Within the class, very first thing I have is a 3 member functions in a public section. Init, which takes a 1 integer parameter and return type is void, and then I have a set function, which takes the constant character pointer, and then it takes another parameter of type integer, that is id, and then another third parameter is a integer type as well. And then I have on line number 9, I have a display function. Okay, that the prototype for the display right here. In the private section of the class, I have a character pointer. So character pointer is going to be used for pointing to an array, okay, that will be created within the init function. And then I have actually it will be a character string that is getting created. Okay, the array will be created for the character string. We'll see the code. And then at line number 12, I have a data member of integer type m underscore and id num. And then at line number 13, I have a data member m underscore and h. So let's look at the code for each member functions. So in an init member function, as you can see, the init is in the scope of C employee, okay, with the scope resolution operator, and then it is taking a 1 parameter. So basically, as we have discussed in the start of chapter number 2 about this pointer, in this parameter list for the init function, there is a this pointer. Okay, and that's how this member function knows where the data members are located in the memory. Okay, so in this case, data member MPC name. Otherwise, it would not know. So if you if you want to review this pointer, please go back to the start of this chapter 2 and review this pointer. So at line number 17, I am allocating the array of characters, okay, of size, some size, and basically new. So this PC name is what? Is a data member within the class, right? So PC. So I have this PC name, okay, name, and then array of characters, okay, of some size, whatever the size is going to be. Okay. So each element will hold the character, okay, because that's what this you are saying, the character, and then this will be the new this PC name is going to be where? This PC name is going to be within the object, okay? But wherever the object is going to be, okay? The object in this example that we're going to create is going to be on the heap. But at the same time, we're also creating this array right here on the heap, okay, at some address location, 5000. So this PC name will hold the address 5000, and that's how we'll say this is pointing to the first location of the character array. And then at line number 18, all I'm doing is initializing this array with a null pointer, this character. So to making sure that every element of the array is a null character in here. But look at the size plus 1. Okay, so that means whatever the size is, we are going one extra. But there is a problem, a small problem. Okay, what is the problem? The problem is that we allocated the memory for this size right here. Okay, whatever the size. And then we are going one extra. So at this point right here, if you don't fix this program, it will crash. So what we have to do is we have to say right here 5 plus 1 right here. Okay, that will fix that bug. So you see, these kinds of bugs are very easy to create just by forgetting to put a plus 1 in there. If you don't put that, then at line number 18, your program will crash. So at line number 20, we have a set function which is a member of a C employee class. Okay, and in that case, when the set function is called, all it is going to do is to whatever the character string that we have passed to this function, it will copy that character string, so string copy function. Okay, the regular string copy function from C++ is called, and it copies this string into this array right here. All the characters will be copied to there. And then at line number 23, the ID will be initialized to the data member. And then similarly at line number 24, A will be initialized to each data member. And then at line number 27, I have a display function starting. Okay. In this display function, basically it will be reading the data from the memory and displaying it on the screen. Okay, so the same way, so it will display whatever the data is there about the name, and then the ID and age. And then at line number 32, I'm basically, after displaying it, I am deleting this array right here. Okay, I'm deleting this array. So I'm checking first if this pointer is pointing to something, then do the delete. Okay, and also I'm making sure that I have a square bracket, otherwise it's going to delete this first element. Okay, so if this pointer is pointing to something, then do the delete, so then it will just delete this whole array. Okay, so I'm doing, basically it's not the good way to do it, because in your functions, you always should remember to do one task. In this case, the function name is a display, so I really should be only displaying it. I should not be doing this. Okay, I should have it in a separate function, remove function or something, and then call it separately. So the purpose that I have this in the code, and as well as this plus sign that I did not put it in, just to show you how easy it is to make the mistakes when you write the code. Okay, so this is not the line number 32 is not a very good code writing practice. So in the main, as you can see, at line number 36, I am creating a pointer of type worker data. So this is a pointer, okay, and then worker data. That's the name of this pointer. This will be created with some address location and 1000. Okay, so this pointer is created there on the stack. And then I'm saying new C employee. Okay, so that means I am creating an object in the heap. So this pointer is right here. This pointer worker data is on the stack. Okay, and then the object that I'm creating, C employee. This is an object. Okay, in this object, how many things will be in this object? The name, okay, ID, and age. These three things will be there. When we do this, and then this object will be created at some memory location, let's say 7000. So the new operator's responsibility is to pick up this address 7000 and assign it to this pointer variable. Okay, 7000. So now this is pointing to right here. Once you have created or allocated the memory for this object right here, then you can basically access it, okay, with the pointer variable. And that's what I'm doing at line number 38. So I'm using a pointer variable to access this member function init and passing 20. So in this case, the 20, what does the 20 means? So 20 is what? A size. So what is the size? Size of this array that it will allocate, the dynamic allocate that we were talking about. So init function has a new operator, okay, that allocates the that big of an array, 20. So there was a bug in there, as I told you, that so I made it when it is allocating the memory, it is allocating size plus 1. So it is actually going to be allocating 21 character long array. And then once the array is allocated, in the init function, in this init function body, if you go and see it, I was basically making sure that the array has all the element has a null character. Okay, so I did the mem set in that init function, and then the set function. The set function, as you can see, I'm passing this string. So this is a constant string. So this is very important to remember as well. So this const, that is the purpose, that is the reason that we have to put up const. So the GNU compiler will not compile, or it will give you the error if you do not put const, okay, or it will say deprecated. So const char star n. The purpose that we have to do that is because we are passing this constant string, okay, in a double quote. And then the next one is a ID, okay, and then the last one is a 47 is an age. So it will initialize all these data members that we have with this data. Okay, so the init function literally will have an array that we saw in the when we were drawing it. Okay, so this name will be pointing, because name is what? It's a pointer variable within the object, so it's pointing to the first element of an array, and then init function is the one which initializes the whole array with a null character. Okay, and then the set function basically initializes each element with each character. Okay, so J will go there, JOH, and SON, and then the last element will be the null. And then, as we saw, the display function body, it displays this data right here that you see. Okay, all this data, and then it removes this array, right? And that's the time that I told you it's not a good idea to do the delete of this array within the display. Okay. So I have a delete within the display. Okay. Now this delete is for what? That the delete that you just saw. So let's go back to display. So this delete is for removing the array from the heap. Okay, this array. And then this delete is for what? This delete is to remove the data object pointed by this PTR worker data. So this is for deleting this object. Okay. So how does this goes out of scope? Worker PTR worker data. This is a PTR worker data. How does this go out of scope? It will, since it's on the stack, it will go out of the scope right here, right before this program goes out of the scope, or right before this program ends. This is the end of Unit 6, Chapter 2.